some videos of what people have done, like a Rubik's Cube and the
I think
the Segway.
about pianos. We didn't see that.
Oh,
Yeah,
okay.
Lego mindset at all.
That could be it. Because I'm teaching two sections of cisp300, so sometimes it is harder to remember which one is which one.
And those are really cool, but they're also the most expensive Legos out there. So
Absolutely, and the older version is more expensive than the new version too. So that tells you something about it. I'm gonna pass the roll sheet in about 15 minutes or so, just so that I don't have to pass it out again. Okay, so what I do want to show you guys is the Lego Mindstorms and also App Inventor. App Inventor I have shown you already, but I'm gonna show you anyway again, but this time with a little emphasis on a different part of it. So I'm gonna go to the Lego Mindstorms drawer inside the they call this the palette. Yep. So there you go. App Inventor is basically a program development environment for the Android tablets or phones. Okay, so it's for mobile devices, but running only on Android. I think if anyone has written one for the iOS, it would not be releasable anyway. Apple would not have allowed it. But for Android, it's an open platform, so anyone can write anything they want to develop apps. So this is a quick and easy way to write apps on the Android platform. But it has the Lego Mindstorms component too. And if you click on one of these things, it shows you what it does. So if I click this one, it says a component that provides high-level interface to a Lego Mindstorm NXT robot with functions that can move and turn the robot. It can also interface to the ultrasound sensor, which is a distance sensor, touch sensor, sound sensor, and so on. Now, granted, this is not a super duper robot kit where you can do just about anything like vacuum and mow your lawn with it. But it's fun. I mean, it definitely is fun. The built-in controller, the brain of the robot, the NXT brick, as it is called. I think these days, people don't want to call a controller a brick anymore, because breaking your phone is not a good thing. So you don't want to call someone a piece of brick to begin with. Anyway, it's very limited. Okay, you can only do so much with it because it has a fairly old processor and has limited RAM and stuff like that. So what this allows you to do is to offload all that processing to an Android phone or tablet, and you can do it remotely using Bluetooth. So now you can have a robot running around in a room just using Bluetooth to communicate with an Android device. And then on the Android device, not only can the Android app itself provide the intelligence to run the robot to do whatever it's supposed to do, but you can also have a fancy user interface because now you have a tablet, as the front end of the robot. Okay, I can see a lot of potentials, doing this sort of thing because now you're combining robotics with app programming, mobile device programming. Yep, go ahead.
I find it hilarious that you're bringing this up. I'm currently in the middle of creating a 100% electric vehicle, completely self-sufficient. It's a 2002 Ford Think. It runs on 72 volts. I have photovoltaic, polycrystalline panels that I'm using, and what I want is, and I currently use an app, but I'm looking for some type of interface because I have robotics on top of the vehicle itself that when I park, the function of latitude plus the function equals what angle my photovoltaic panel should be at wherever I'm parked at. It's on 3 axes, so I manually have to control it at this point, just monitoring amperage that comes out of each cell. I was just going to ask you, how robust are some of these Lego components that?
Well, the Lego.
I'm looking for something that I can. I mean, a Bluetooth application is perfect. Like I just have a small app inside the vehicle.
I don't think the Lego motors are really up to what you need. So what you need are the industrial type of control solutions. But it will still be usable, in terms of having a Bluetooth. A model would be nice using Legos. I just want to show you what people have done with the Lego NXT Mindstorms kit. This one is kind of interesting because they're implementing a Lego Segway, basically. Okay, it's kind of like a Segway. You know, it has 2 wheels, and the thing has to self-balance. And it has a tilt sensor, you know, on the robot itself. It's actually a part of the kit. And right now it's balancing by itself. And the guy is now trying to disturb it by pushing it. And you can see how it's, you know, balancing itself again. And I think, you know, this is interesting. I mean, this is, you know, something that you normally would not think about. Hey, you know, I can do something with Legos.
It responds pretty quick too.
It is very quick. It is very, very quick. I will bet you, you know, whoever programmed this, you know, can also program it to go forward and back, just like with a Segway, where you can lean forward, you know, and, you know, make it go, you know, forward and back. So I think, you know, this is interesting. So if you look at this and then you look at, you know, app programming on mobile devices, you combine the two. I mean, that seems to me is a really, really cool combination. And now it's remotely controlling it. And it's wireless too. You can see that his remote control wire or the cable is not connected to the robot. I think it's connected to a computer that interprets the signal and then send it to the robot through Bluetooth. All right. So some of you probably are thinking, okay, I'm going to get on my phone right now and want to buy one of these NXT kits, right? So I will save you the trouble because I'm going there myself. So you have, I think, you know, even though a class like this, you know, really should focus on, you know, programming and stuff like that, I think sometimes it is important to remind ourselves, you know, why we are doing this, right? I mean, why are we learning how to program? This is the new kit. EV3 is the new kit. If you go for the old one, which is the one that was showcased, it's called the NXT kit. It's actually more expensive.
Why is it more?
I think it just has more compatibility, you know, with existing stuff that people have done already. And I think Lego has stopped making more of the NXT kits, so it's limited. Whatever you're buying is limited. When they run out, there's no more. And I saw the price, you know, going up. You know, I bought mine years ago for $200, which I thought was, wow, that was expensive. You know, $200 for a Lego kit, and now it's like 3 times. Okay, you know, I don't think, you know, depreciation, you know, accounts for, you know, a 3 times, you know, increase in terms of the price of this unit. Okay. But what people have done with it is just amazing. If you just go on to YouTube and look for Mindstorms NXT, you will find out, you know, what people have done with it. Some people would use 2 controllers, you know, tethered to do some complicated robotic stuff. So it's just amazing to me, you know, what people are doing with these, you know, so-called, you know, toys or educational tools. But it's really kind of, people have taken these stuff, you know, way beyond, you know, what it was originally intended. Yep, go ahead.
Is the new one more geared towards like being more like a toy than the NXT was?
I do not know. You know, I haven't really read any comments regarding the new one. The first thing I would look is whether it is NXT compatible. It doesn't look that way. And you have systematically missing parts. Okay, instruction to build one. I have no experience with the new one. I would imagine the controller, the brain part of it, is more advanced. You know, you can store more complex programs on this newer unit. But even so, you know, those bricks or the brains built into the robot kit, they can only have so much processing power because, you know, once they fix the design, you know, they don't really keep up with, you know, technology. Whereas your cell phone, your tablets, you know, it's always has the latest and greatest, you know, quad-core, you know, processors. Who would have think a tablet would have quad-core processors, you know, like only about 5 years ago, right? I mean, so to me, you know, this is really quite amazing. What, you know, how fast technology has advanced and what people have used, you know, technology to what they're doing with technology. Before we move on, you know, back to, you know, nested statements and the new homework assignment, let me ask you one question, because I'm actually cheating, because this is something that I'm supposed to do, but I'm letting you guys, this is crowdsourcing, right? Why are you guys taking this class? Why are you interested in computer science or CIS in general? I know some of you are not, majoring in computer science, but still, I would like to, collect your, opinions. Anyone? Okay, go ahead.
I'm a math major and it's required.
Okay, you don't know why. I can actually tell you why. If you have a math degree, getting a job, can be a little bit challenging. Okay, unless you want to teach or do something that only requires math skills. But if you combine mathematics, especially applied math, with statistics and computer science, you will be very employable. Okay, there are a lot of jobs that require mathematicians, because you cannot rely on programmers or computer scientists to do the math part of modeling. But yet the mathematicians typically do not know how to write programs, so they can tell you everything theoretical about a model, but they cannot write a program to automate the model. So combining the two makes you very employable, very valuable to investment companies and so many other type of jobs. Okay, go ahead.
I'm a mechanical engineering major. The reason I decided to pursue this degree was I want to design and construct and build my own aircraft and vehicles and whatnot. And a lot of what I want to do requires extensive programming, because there's so much going on with the vehicle or the aircraft.
Absolutely.
That you can't control it. You need computer systems to control, like, one vehicle I've designed uses thrust alone to keep it in the air. And I know, especially with very simple models, you have to have extensive computer programming just to tell it how to control that thrust to keep it vertical.
It's just like the Segway, except yours is even more difficult, because it's not even on the ground. So you cannot just shift its way back and forth to keep it balanced, right? You have to deal with a 3D situation, and then plus the tilt.
Especially while it's moving, and you have different you have aerodynamic aspect as well as just gravity and G-force.
Yeah, I'm just gonna interject a little bit of stuff here, and I'll get back to the other people who want to kind of express their opinion. What is the name of the latest and greatest US AF, the Air Force fighter? Is it the F-822 now?
It's 35.
The Raptor 35?
35.
Okay. Okay, but that's not the first model that required extensively on computers for flight stability. If the computer on that airplane shuts down for a few seconds, that thing is going to drop like a rock, with no control whatsoever. With the older airplanes, even with the jets in like the Tomcat, if the computer shuts down, the pilot actually still has pretty much full control over where the plane is going. Okay, it's still going to fly really kind of down really quick, but at least the pilot can control the general direction. With the new airplanes, it is so aerodynamically unstable that it is impossible to control the airplane manually.
But they're designed like that to be more maneuverable, because with when you design it to be unstable in the air, it twitches really fast to side, around corners. So
Can the person inside the airplane take it?
That's the whole.
So you basically have to, well, but there's one easy solution to that problem, because if they can easily pre-program like an evasive, evasive pattern 1, right? So in case of any type of situation that calls for evasive pattern 1, the pilot just punched that button, and the plane would do whatever it needs to do, and then the pilot would black out or red out, depending on what the plane is doing. But the pilot may survive, because the plane can pull that trick when the other side is not expecting the plane to be able to do that sort of thing.
Yeah.
Yep.
Kind of
But
bad.
sorry.
Bad side to that though is if you get hit by an EMP or some kind of electrical thing.
Yeah.
They harden the electronics on those airplanes, so they are less susceptible to EMP type of interference. But yes, there's always that chance.
A little
that-
glitch or something.
Yeah, but almost everybody now have electronics on their aircrafts. So EMP would just disable, just about everybody. The biggest problem is hacking, because hacking is specific. Okay, if they tag onto the digital communication, onto the airplane, they can target, specific teams, particularly specific airplanes, and that would be bad. But a general EMP, from let's say a small nuke, exploding at a certain altitude, would just disable everybody. So,
But
people
if you're like a
usually
neutral
probably
party,
do
you
it.
just want to screw with everyone.
Yeah, certain neutral countries, right? Yep, go ahead.
I worked at a manufacturer here in the area and kind of worked my way up into quality control and got asked to work on the network with the network administrator. Well, then he left and started learning under him to understand the programming that had been done prior to him taking over and what he had done. And when he left, then I was on my own and found he, along with other guys, had hard-coded all acceptable dates. And so when we got to a date, 2013, 2012, which they hadn't accounted for, they knew that they would have to go in and adjust the date range, but I had never had to deal with something like that. And so I started looking through the code, and I'm looking, and I, just having to understand that from a layperson's terms, not having taken a programming class before, I started realizing how important, even my background prior to that was science. It was, biology, environmental studies, and stuff like that. So that, taking on that role, it kind of showed me that, even not knowing where my career was going to go, I still needed to have some basic knowledge that
it's becoming somewhat like a basic skill in terms of getting employed these days, especially when you're talking about higher end type of jobs, knowing how to read programs, not necessarily developing your own program. It's kind of like a basic skill now, which is kind of interesting. It's going along with like math, algebra, and English writing and reading.
Kind of ended up being on that borderline where I was someone who was in production for a long time and could understand what was happening behind the scenes, and that's why they asked me to transition. And that became, but still, you need those basic skills if you're going to make a transition like that.
If you don't have them, I mean, everything's done digital, so.
Yep, they are. Okay, go ahead.
I'm a biomedical engineering major, so this is kind of necessary, but I kind of assumed that I would start failing the class as soon as I got into it because I'm terrible with computers. But I'm really enjoying it and considering switching my major to something with programming in it.
I wouldn't give up your original major.
Oh, yeah.
You can. I would recommend everyone to consider double majoring or have one major and one minor, because if you think about it, okay, the playing field is more level now. I mean, companies are doing H-1B, visa to bring in people from other countries to work here, and they're also offshoring, jobs and projects to other countries. They're bringing entire teams outside the United States to go to another country for not just for manufacturing, but also for design and engineering. Okay, so you have to ask yourselves, okay, certain countries can pump out computer science major graduates like there's no tomorrow, just because they have a lot more people. Okay, so and they are also less expensive. Okay, they will only require like 1/4 or 1/5 of what you would need in order to make the same level of living. Okay, so you have to ask yourself, how can you make yourself valuable enough to your employer to basically say, I know I have to pay this guy like 5 times as much money, but in the end, I'm still saving money because because of what? Okay, you got to think about that. Okay, if you're just talking about programming as a developer, I can tell you, offshoring, is the way to go. Okay, that's the way to save money for these big corporations. But when it comes to combining programming, developing a program with something else, I don't care what is something else. Mechanical engineering,
biomedical engineering.
Biomedical engineering and whatnot. The combination of the skill set is what is going to make you valuable. Because you not only do you understand just the mechanical design part, but you also understand how programming can enhance the mechanical part. Or in your case, how you can Give me one example of applications.
Prosthetics and
Okay.
the organ printer.
Yep. And even automating physical therapy can be a big thing, right? I mean, you guys know, most of you know what is physical therapy. You know, people with injury and whatnot. They need to basically redevelop certain types of muscles and other parts of the body. Well, even the diagnosis of that can be helped with computers, because they can basically just give activities to a person, and the computer can control the strength or resistance and record the entire motion and say, okay, this person can do this motion here, but it's kind of stuck or weak at certain points. And once you can collect that information and possibly to look at the thermal imaging of the person at the time and whatnot, you can probably do diagnosis a lot more accurately compared to just asking the person, okay, where do you feel strain? Okay, where's hurting? Okay, but instead if you use a computer to record all that data, and then once you have a diagnosis and say, okay, I think you need to have this kind of exercise, you can automate a machine to program it to just the right resistance along the right axis, for the person to have the physical therapy. And then you can collect all the data, while that person is doing it. You can show the progress to the person. You can show the progress to the therapist, to decide what to do next and so on. So I can see endless possibilities, when you combine mechanical engineering, biomedical, engineering, computer science, AI, artificial intelligence, and all of this stuff, they will all kind of merge at some point to make products that are just almost inconceivable when you look at individual fields by themselves. Well, I'm crazy, so sometimes I just talk about stuff like that. Just also imagine if you have Google Glasses, throw that into the whole process. I mean, you guys are getting the idea, right? I mean, if you just look at one thing and you just say, okay, down the line, what are we going to see in this particular field? It's kind of limited. But when you try to mix in all the other stuff, even someone who's writing science fiction will have problem figuring out how all of these things will interact in the end. And that's what we are seeing. Okay, that's what we're seeing. We're seeing the fusion of different types of technology, approaches of doing things, and it's creating things that people just cannot foresee. All right. Any other person want to kind of chime in and tell me why? Yep, go ahead.
Computer science major, but I've tinkered with computers for about 20 years.
Mm-hmm.
So, and I never did programming. I was more hardware and just programs and all kinds of stuff, but never got to the programming aspect. So it's gonna be really interesting, and plus all the Android stuff fascinate me. But money too, because I was an HVAC technician for like 5 years, EPA certified and everything, and the job market just.
Yeah.
So it's like, I'd rather make some money doing something I know. So.
Go ahead.
Mechanical engineering, the same thing. And it just, to be honest with you, I worked for Ford Motor Company for 13 years. Ended up as a foreman, and then started service engineering concepts with Ford. And as I would introduce these things that I was coming up with in my garage, somebody would walk up to me and say, well, that's essentially this. And mine's this big, and it's got all these physical components as far as relays and timers and rheostats, and they say, well, you just pretty much made something that came out 4 years ago. And I'm like, I'm all pumped up about it, but it's absolutely nothing in the world today. So I'm like, okay, well, there's this huge gap that I need to fill between what I want to occur, like him and yaw rate and things like that, and how I can get it. And yeah, I'm pretty sure there's a mechanical way you could do it, using a pendulum or something like that. But it's just being trumped tenfold by this ability. This ability to process information.
That is
the speed at which.
Yeah, like you said, 90% of Ford Motor Company. I actually, after we did the whole Google Glasses thing, I contacted an individual, and they're considering that as an ESST, so it's an essential service tool, which is required to work on a vehicle. Like, let's say to remove a seal or something, there's an ESST for that, a specific tool for that. They're actually considering that as an ESST for validation of repairs and inspections of repairs. Right now, they have to submit paperwork, submit pictures of items that may be broken or questionable. Whereas they say, okay, we're going to go ahead and have you go ahead and stick on a set of goggles, and we're going to follow you through the repair.
We'll take a quick look here.
Yep, there you go. That's essentially it. That's the first thing on the toolbox.
Yeah, it's fun.
I'll just show, like halfway through it, just so that you guys get the basic idea of what it is. So he has augmented reality. The computer is now, augmenting what he's seeing and telling him, what screws that he has to take off first.
The reason why I left the industry is simply because of this. I'm not kidding you, because you're not going to pay a $45 an hour technician to do this. You're going to pay it, well, at the end of 2014, it's going to be $10 an hour, but you're going to pay a minimum wage individual to put on a set of glasses and a regular.
Once they can do this, what is stopping them from making a robot to do it?
Yeah, absolutely.
Are you guys getting the idea?
The variable is a human.
Yep. Yeah, so I'm just gonna stop here because the rest of it is really just more of this stuff here. But you guys get the basic idea. What he's seeing through his augmented reality is superimposition or super imaging of the tool and the instructions and whatnot. But as I said, if the computer can understand the 3D distance to the object, the orientation and everything, what is stopping people from using a robot to do exactly the same thing? Because you already know the position, you already know the orientation, you already know the procedure, you already know the torque that you're supposed to use to tighten and to loosen something. Why not just use a computer? Yep.
But the thing is, once we get to that point, we'll need someone
Lego
to
guy.
repair the robots that repair the cars.
We'll have robots to repair robots. I'm not kidding. Only up to a certain point, then the system itself can become autonomous.
We just built robots that
Then humans
take
become
care of the
obsolete.
other robots, take care of the other robots, take care of the other robots, and the ones at the end, we just let them die.
The humans will just be there to pay the bills.
Yeah, really, yeah.
Okay, who racked up $500 worth of nuts today?
We just did a tour with a club on campus to a manufacturer.
Okay.
And it's a huge building, and they had like 3 people working there. Everything's working. Everything's automated. That's where it's going.
That's where it's going. Exactly.
It's kind of scary.
Well, I guess I'm taking this class mainly for prerequisites, but basically,
That's okay, too.
I currently have a position where I'm programming a home automation system, and it's going to be using Android and a few other things to basically figure out what you're doing at every given time, what your schedule is at any given time, and it's going to do things in the house accordingly. It can remind you when you're low on any sort of groceries or if anything is happening or where anyone else is.
in the refrigerator.
Well, it would even go as far as to detect when you're sleeping or when you're out of the house, and then it would adjust temperatures accordingly.
Okay. That's interesting. That is
Imagine
definitely
a
interesting.
smart house on Disney Channel.
Right.
That's a terrible idea.
That's true. She locks it down.
It's
Kill us.
If you've ever seen the movie, I think it's called Demon Seed. It's like a really bad
Is it
80s
like
film.
Rosemary's Baby 2 or something?
It's really out there, but a home comes alive and it like kills people and impregnates a woman. It's really really strange. So
Is this one of those animes?
And then before all of that, we have
Christine!
Christine, of course. Yes, that is way ahead of its time. They just didn't show you the tablet, right? All right, so getting back to the boring stuff. Yes, go ahead.
Do you think they'll kind of lean to be more evil, or I think they'll be more good? I mean, kind of like
it's however you program
program
it.
into it.
You ever watch Battlestar Galactica? It doesn't matter. We keep going, we keep going, we keep going. It's the same process that happens over and over.
Actually,
Slaves rebel. There are slaves.
it's Gattaca. No, Battlestar Galactica is the prequel of it.
Stargate.
No, that's prequel. The prequel of Battlestar
See, it's
Galactica.
Tapper Pack.
What is the name?
Caprica?
Caprica, that's it. It's Caprica that is interesting because that is the lead in to all the things about how come the robots have religious beliefs and whatnot, and the creepy part is it's not really that impossible. Okay, putting a person, reconstructing the mind of a person, virtually, from everything that was observable about that person, can actually potentially be done. Okay. And before all of this stuff here, I'm just going to write this on the whiteboard. We had HAL 9000 from 2001: A Space Odyssey. Okay, it's not evil. It's not good. It is a tool. It depends on how people program it and what directive people tells it. Right? It went crazy and killed people only because it had two conflicting directives. One is to assist the astronauts. Two, the other one is keep this a secret. Don't let anyone know about it. Oh no, that's bad because these guys know about it already. So I better fix that situation by killing them, right? And of course, in 2010, the movie 2010, HAL 9000 actually became one of the quote-unquote super beings. It was recognized, for his intelligence and whatnot, and he was actually elevated, to be one of the monolith members. Yep.
Have you heard of the tool printer, where you can put a wrench into a printer and it'll print out a wrench?
Yeah.
Yeah, it's a 3D printer combined with a 3D scanner, right?
Yeah, and you use it in space.
Well, in outer space, you also have all kinds of interesting things that you can do that you cannot do under gravity, because under gravity things can only go down, right? Because of gravity. But in outer space, you can grow crystals and other things, and there's no gravity to control, to dictate which way it has to go. So there are interesting possibilities there.
I read that they were going to do printed food in space as well.
I'll just have it teleported.
Well, they have the oven.
Matter reassembly.
Yes, exactly. Recycling, actually. All right. So getting back to the boring stuff, I'm sorry we have to do it. Otherwise, roll sheet. Thank you. Because otherwise, someone's going to complain to the dean and say, "Tech is turning this class into an infomercial," and I don't like it. So we got to get back to the usual boring stuff at some point.
Get it out now before we go to the next class.
All right, so here's your next homework assignment. It is about nested statements. And this is the homework assignment. Let me just zoom in a little bit so that you can see a little better what it is. And I will tell you how to proceed from here, okay? I'll give you some general directions of how to proceed from here. It's an algorithm that has nesting, right? Because we have a single assignment statement on the outside, which is right here, okay? And then we only have one other statement at the top level, because the second statement at the top level is a loop, okay? So at the top level, we have, if you want to look at this from the file analogy, we have one file and one folder at the top level. Now, when you look at the folder at the top level, which is the while loop here, this is its content. Everything between the while and the end while is the content of the while loop. And you look at this content here, there's only one thing. It is another folder, because it is one single big conditional statement. Okay? Only at that level, the second level. When you look at the conditional statement, you have to identify its parts, right? Line 3 is the condition of the conditional statement. Line 4 is what we do when the condition is true. And then line 6 to line 10 tells us what to do when the condition is false. Okay? But when you look at line 6 to line 10, that by itself is another conditional statement. So, well, since it's another conditional statement, we also have to identify the three parts that come with a conditional statement. In this case, it actually has more than 3 parts. It has 3 parts, so to speak. It has the condition to evaluate, and then we have else if here. This is actually a multi-branch conditional statement, because if the first condition is not true, then we move on to the second condition and see whether that is true or not. Okay? Within this multi-branch conditional statement, we finally have the last or the lowest level of statements, which are these assignment statements on line 7 and also line 9. Okay? And I want you to trace this algorithm to its completion. Okay? In other words, you start with the precondition, and then you keep tracing it until we get to the post, or until we get out of the while loop after line 12. Okay? It might look kind of daunting because wow, this is like a lot of stuff. But when you trace it, I guarantee you it's not going to be a very long trace, even though we want to keep x in the loop as long as x is less than 20. Yep.
So I've already started it, and I just have one question. So on line 5 and 6, you have else on 5 and if on 6, and then on 8 you have else if. Is there any difference between those two statements?
That's a good question.
Because it kind of made me question whether I was doing the process correct or not.
Okay.
So kind of bounce back to our last lesson.
That's a very good question. The concept of else if as on one single line in this class is a construct that does not exist in C++.
Okay.
Okay.
So it's just our terminology.
Okay. So that's a very good question. Let me just kind of digress a little bit and show you a picture that will compare the two approaches of doing multi-branch conditional statement. Okay. So the first example is to say, if I'm just going to use C1 as a condition, so C2 is going to be another condition. Okay. So if C1, then we have statement STMT statement 1, else if C2, then we have statement 2, else we have statement 3. So at this point, I'm not even concerned about what C1 and C2 are, what statement 1, statement 2, and statement 3 are. I'm just using those as placeholders because I'm going to draw a picture representing exactly that logic. Okay? So this is one way of doing things. And then the other way of doing things is like this. Okay? If C1 then, statement 1, so this part stays pretty much the same as before. And then you have else, and then you have another conditional statement inside it that says if C2 then, statement 2, TMT2, else, statement 3, and then we have end if here, and then another end if here. Okay? So we're comparing these two ways of looking at a multi-branch conditional statement. And the first question is, are they the same? Are they functionally the same? Would they do exactly the same thing?
I'm going to say yes.
The answer is yes, they will do exactly the same thing. But the second thing is, do they look exactly the same in terms of the picture? Okay, when you draw a picture of these two, are they the same? That is different. Okay. The first approach, I'm going to highlight it so that we know which one we're talking about. This one, you can do it in only certain programming languages. Visual Basic, you can do it. Perl, you can do it. I believe PHP can do it as well. Okay, because you need that word called else if. Okay, and it's spelled differently depending on the language. In Perl, I believe it is else if, E-L-S-I-F as one word. In other languages, it is spelled as else if, E-L-S-E-I-F. Okay, but nonetheless, it depends on that special keyword to do something like this. All programming languages, all structured programming languages that I know of can do this because this is just if then else, but it is in a nested way. Okay, C, C++, Java falls into that category. Okay, so those languages do not have a native else if keyword. Okay, so you cannot do the first approach. You can only do it in the second approach. Okay.
So it seems as if we're looking at a branch within a nest, correct? Is that what this directs to?
You mean the second approach?
Yeah, correct. Well, in comparison of the two.
Functionally, it will do the same thing. Let me show you why functionally it will do the same thing. So let me just draw really fast pictures in this case to kind of show you what they look like when we look at these in a graphical sense, because they are similar and related, but they are not actually the same. Okay, the first approach, I'm going to draw a picture for the first approach first. The first approach is a single statement. In other words, it is a single multi-branch conditional statement, and we have the first branch branching again later on. Okay, So this is what the first one looks like. We eventually have the 3 branches, but the second and the third branch are actually at the same level. And then when we are about to exit, they all merge at the same place before we exit from the entire multi-branch conditional statement. So this is what it looks like, using the first approach. If I were to label this, then I would have C1 here to make a decision which way to go. If C1 is true, we go this way. If C1 is false, we go the other way. And then if it is false, we have another condition to evaluate at this point, which is our C2. If C2 is true, then we proceed this way. If C2 is false, we proceed the other way. And then here we have our statement 1, statement 2, and our statement 3. This is the picture corresponding to the first approach using the else-if construct. Are we doing okay so far with this picture? Okay. So yes, it's important that you have to evaluate C1 first, and then depending on whether C1 is true or not, you decide whether to go for the second branch or not. Okay. Now the second picture that I will draw is corresponding to the second case where we have a conditional statement inside a conditional statement. So let's go ahead and draw that picture. We're going to use size. All right, so now we're going to draw the second picture. Now the second picture from the top level is a single conditional statement, okay, with only 2 branches. So when you look at the picture, the overall picture of the second approach, this is what you should be seeing. They're asymmetric for a reason, because one side actually has a little more stuff in it than the other side. Okay, I know it's not really that well drawn, but close enough. Okay, so this is at the top level of the conditional statement of the second approach. Okay, so we still have C1 here, and we have statement 1 here. But we don't have statement 2. This is the true branch, and this is the false branch. Okay? It is not completed yet, but at the top level, it looks like this, because it is a conditional statement, if then else, okay? 2 branches. The false branch, on the other hand, goes into another conditional statement. So if I were to highlight it, we are dealing with this one now. So now if I draw that picture, that means here we should see another conditional statement. So if I draw this one, then we'll have a second conditional statement here.
This looks like what we refer back to as far as our conditional statement, correct?
Correct? What? Sorry?
I'll let you finish.
Okay. So now we have the second conditional statement, true branch, false branch, and then we have statement 2 and statement 3 here. So structurally speaking, they are different, even though functionally they are the same. Okay. So this is the second approach. We have 2 conditional statements, one containing the other. But with the first approach, there's only one conditional statement. It has multiple branches and multiple conditions, but it's considered as one single statement. Okay. Are there any questions about this? Now you have to be extra careful because C has a very kind of funky syntax when it comes to conditional statements. Okay. And you have to be very, very careful because I'll just give you an example of what a common mistake is for people who program in C. Okay. The thing about C is, this is just a usual kind of general syntax here. So you don't have to use curly braces to enclose the statement or the things that you want to do. Okay. So if you just want to increment x, in this case, in C you can just say x plus plus, which is increment. Okay. And then you can have else. Okay. If x is not less than 4, you can do something else. No problem. I can just, let's say if x is greater than or equal to 4, I want to reset it back to 0. I can do it like this. Okay? Not a problem. On the other hand, if you want to do just one more thing for the else, okay, let's say you want to reset it back to 0, and you also want to increment y for whatever reason. Okay, so you want to say y plus plus. You might think that, oh, that's easy. I'll just say y plus plus right after x equals to 0, because the indentation seems to suggest that both of these are in the else branch. That is incorrect. Okay? In this case, y plus plus is actually outside of the conditional statement altogether, but it is syntactically correct. Okay? So when you program in C, you have to watch out for these little things, because if it is syntactically incorrect, it's no big deal, because the compiler will catch it and it will give you an error message, and you cannot proceed any further until you fix it. But this is actually syntactically correct, but it will do the wrong thing. Yep.
Do you have a compounded then statement? So if x less than 4 and y less than 7 or something like that?
Yeah, you can do and in the condition. This is the way to fix the problem, because you need curly braces to say that, oh, x equals to 0 and y plus plus are inside the same block. Okay? But the blocks is optional when you only have one single thing to perform as a part of the branch. Okay? And a lot of people are lazy and say, well, I only got one thing to do, I'm not going to use curly braces. But later on, they go back to the same code and they figure, hey, I got one more thing that I have to do for this branch of the conditional statement. They just add one more statement to it, like what I did. And it looks okay, but it's not okay, because that's not how the syntax specifies how to deal with the else branch. So you've got to be careful when you're programming in C. Personally, I would throw in curly braces all the time. It doesn't matter what it is. In fact, you will see me, not in this class, but you will see me writing programs like this way. Okay, if I wrote programs in C or C++, I start with this. I don't even care whether there's something to do in else or not. I start with a template like this. Okay, and then I would go back and backfill the individual items. Then I'll go back here and fill in the condition and specify something to do for the then portion. If there's nothing else to do for the else portion, I leave it exactly like this. Because
gotta change it.
Because in case I have to come back and specify something to do for the else, I'm all set up. There's no way I can do this wrong at this point. Okay. The extra lines may look kind of bad in the program because it's not really doing anything, but it doesn't take up any extra code once you run the program. It doesn't take up any execution time. It doesn't take up any extra memory when you run the program. But you are now ready to specify what to do when x is not less than 3. Okay, when you need to revise the program just in case. Okay, so this is just little things about actual practice for programming that I find useful myself. But did I answer your original question about the two constructs?
Yes.
Okay, very good. That was a good question. So, yep, go ahead.
I noticed for assignment 1, you said that it was graded. How do we where do we go to find our grades for?
You can go to the grade book. You can go to administration, and in your case, if you go to course administration, there's only one item here, which is grades.
Oh, okay.
So you can look at that. You can also go back to the same homework assignment, and it should reflect your grade in the homework assignment.
And when you grade it, do you actually go back and point out mistakes?
Not for the first homework assignment, because that's really just checking to make sure that you got the tool installed correctly. But from the second homework assignment and up, yes, I will give you feedback. Okay. Depending on a particular submission and how far it is from the answer, if it's a silly mistake, I'll just point out, okay, you made a little silly mistake here, and that's why you got like 1 or 2 points taken out. No big deal. If it is completely off the mark, what I typically would do is to say, refer to my solution in class. Okay. That's probably not something that you want to see, because that usually means the score is pretty low. All right. Right, that reminds me, I have to go over the homework assignment that was due today, and this is the new one, this is the one due today. So I have to give you the solution to that one first, because sometimes, I kind of lag behind in terms of grading, which is not what I want to do, but sometimes it just happens. But I do want to give you the solution so that you at least can compare your solution to my solution and figure out, okay, am I correct or not? And if it is not correct, why is it not correct? Did I make a simple mistake, or was it because of a concept problem? Okay, so this is the algorithm, and we're gonna open up a new window for the trace itself. And then we'll go ahead and trace it. This is a fairly, simple program to trace. All right, so we have the precondition already stated that we don't know anything about x or y. So we start with line 1. After that, we have an assignment statement on line 1, x becomes 5. On line 2, we have a conditional statement. We have to indicate the condition itself and then say whether it is true or not. Is 5 greater than 3?
True.
It is true, very good. Then where do we go? We go to line 3, and what does line 3 do? Y gets the value of x, so y becomes 5 also. And then what do we do?
Post.
We're done. Yep. So that's the solution.
If we have to do the comment.
Yes, you do have to do the comments when you execute line 2, because you need to basically log why you make the decision to go to line 3 instead of line 5. That's the reason why we have to use the comments column.
Line 3, if you wrote like 5 and 5,
Oh, you got
that'd be
1, 2,
wrong.
3, 5.
On line 5, you can write line 5, that's, 5 is fine because, we are not updating x, so it will still retain the value of 5.
Okay. But you don't have to, you don't do anything to that letter.
I would not do that because this really helps to kind of point out which one is updated. But I would not take any points off if you say 5, 5 on row 5 here.
If it helps you to annotate during each line what you're performing or what your answer is, like under line 5, I just wrote y gets value of x.
Okay.
In my comments.
That's fine.
That's just for me during the initial traces. I mean, maybe they'll filter out. You don't mind that we keep extra comments in there.
Yeah, that's fine.
Okay.
Yeah. Do you guys have any questions?
No, we're just discussing that.
Okay. Is that clear or?
Yeah.
Okay. Okay.
Yeah.
Yep.
So I went from line 1 to line 3, and I just put the 5 in there and with no comment. So is that a point off, or is that?
That would be more than a point off because it is very important to go through line 2, because line 2 is, 1 is telling you what conditions you have to evaluate, and then 2, you're also logging why it is going to a particular branch. I understand. I can look at this code and actually come to the post condition like right away, but in this class, it is important that we go really, really step by step. Yep. Mm-hmm.
Now, for line 2, since we already put that in line 1, x gets the value of 5. In line 2, if I put the 5 there, is that wrong?
You mean 5 is greater than 3?
No. X is greater than 3 is true.
Right.
And then in column C, I put 5.
So here you have 5 here.
5.
That's okay. That's okay. It's not necessary, but you can always repeat the value of something that is not changed. I just don't put it there because it really is not an update. So this way I only reflect the updates when I put something in the cells.
Okay, you have a question.
Go ahead.
If it's false, then you would jump from 2
to 5.
to 5. Okay.
Yes.
Okay.
Yeah, you go from 2 to 5, and then x gets incremented, and then post.
Okay.
That'll be the
So
end.
then I get incremented to 6.
Correct.
Okay.
In this case, if I change the greater than to say 30 instead of 3,
Right.
then you will go to line 5, and then x will be updated from 5 to 6, and then post after that. Yep.
So the rows that have else, they never get included in the comments.
I do not trace the line with an else. If you did that this time, I'm not going to take any points off. But in the future, we do not trace the word else. Okay.
said we stopped doing traces after this class, right?
That is correct. In all your other programming classes, there won't be any traces. So, you know, if you do not like traces, you know, after this class, you don't have to worry about it.
I meant that's why you make us do like all the little comments is because of the fact that it's.
It's a good tool. It's good.
Yeah.
We don't learn it.
Good learn.
Because I want you guys to know exactly what is happening on each line. Now, I know some of this stuff here early at the beginning is fairly simple, you know, so it's pretty easy to go through a trace. But when we get to subroutines, you know, that really gets kind of interesting, especially when we start to do, you know, recursion and whatnot. And that's when a trace really, really becomes helpful because you can actually see what is happening, you know, when you have a subroutine call with parameters and all the other stuff.
So I recall you mentioning copy and pasting, where you can tell what's been copied and pasted. And in our new assignment, we've got some areas where we may be able to do that just with our information within our own document. Is that okay to copy and paste a line set or a command set?
Yeah.
That we have. Okay, it's just you're talking about copy and pasting from other areas.
Yeah.
Okay.
Yeah. If it's not copied from another document.
All right. Yeah.
Yeah.
I have done what you did, but I didn't start with number 5. Like after I did number 3, I went to number 5. And
That would be
back
wrong.
to the 2, 3, 5.
That would be wrong. So, you know, so that's a concept issue because, you know, we can only take one of the 2 branches. And when that branch is finished, the whole conditional statement is finished. So that's why, you know, I would give you the feedback and say, you know, well, it's wrong, you know, and you have to, you know, understand the concept itself. It is that would be a concept issue. Any other questions? No questions? All right, so we are done with the homework. And I'm done showing you your new homework assignment. So now we'll go to the dreaded topic 3. You know, I reordered the things a little bit, so now we don't go from topic 2 to topic 4. You know, I just, you know, have topic 3 here. So we're going to talk about pre and post conditions. I'm not sure how many people have read it. Okay, so we'll go ahead and take a look at this. All right. It starts with a slide that talks about, you know, what is this crazy math? Okay, because to some people, you know, when we get into this particular, you know, chapter topic, it will look like crazy math. I mean, you know, this is a programming class, so what are we doing with all this math stuff here? Well, okay, so I'm going to backtrack a little bit here and talk about, you know, year 2000. Okay, the dot-com boom. Okay, I think I haven't talked about it in this class because, you know, we are a little bit lagging behind the evening class, so that's why I ended up not badly. We're just, you know, a little. Okay. So can anyone remember the dot-com boom back in '99 and 2000?
Yeah.
Okay. What happened?
You could tell anything with a .com on it. It didn't matter.
Okay.
Just an explosion.
If it was phonebook.com, it had a value.
Okay. So the dot-com boom had to do with the internet technology was at a threshold to go from, you know, just being connected to corporations and, you know, universities to everywhere. Okay, it is becoming inexpensive enough that you can actually get it, you know, at just about any household. Okay, so it's right at that point when the technology becomes, you know, inexpensive enough and fast enough for that kind of thing. Okay, a lot of, you know, people have different ideas of, wow, that is cool because we can do blah 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 all of these things, you know, using the internet to make money, right? And a lot of people are interested in making money, but they don't have the innovative minds to figure out what to do to make money using the new technology. So they put money and they pull the money together and they give these to what we call venture capitalists. Okay, so venture capitalists, you know, represent, you know, their clients, which are basically private, you know, or citizens with a lot of money and they don't know what to do with their money, right? They just want to say, well, I got a lot of money already. I want to make even more money. I don't know why, but I want more money. Okay, so they give this money to the venture capitalists who will be going out and say, okay, I will look for investment opportunities. Okay, and back then, you know, when the internet technology is right at the verge of becoming household. Okay, A lot of companies, a lot of people have really great ideas of how to use it. Okay, Facebook. Okay, so we still have a few surviving companies these days from that had ideas originating from that time. So now you have a lot of venture capitalists with lots of cash. Okay, and say, I got cash, you got ideas, great. Okay, make me a lot of money. Okay, so they went to the Bay Area, okay, to basically to help these companies to start up, get the people, develop the product, and so on and so forth. When the dot-com boom started, they almost immediately soak up all the existing software engineers, programmers, computer engineers, and whatnot. It just gone. Okay. So where do they go next? To get their employees, the programmers and the people who need to write programs.
College.
They go to graduate school. Okay, that's the next best thing. Okay, so they so they go to Stanford, they go to Berkeley, they go to San Jose State University, even UC Davis. Okay, to recruit graduate students, qualified graduate students to work on these projects, and they were paid a lot of money too. And then quickly, that pool dried up. Okay, all of these graduate students basically put their research on hold, okay, in order to make a lot of money, back in those days. So where did they go once you exhausted all the graduate students? Go to undergraduate, right? No, not quite. Graduate students. They go to graduate students, undergraduate students at UCs and Stanford and whatnot. So once again, we have a whole bunch of students who basically just put their academic endeavor on pause in order to make a lot of money. And eventually they ran out of those people as well, and then they move on to high schools. They move on to high schools. Okay. Now I'm not saying anything about high school students, but they do have a lot of other stuff going on, right? So a lot of times when they write programs, they're basically doing in a hurry. And they're also not experienced, right? They're just starting to do it, but they can see that, hey, if I can write some web scripts, I can make a lot of money. So I'm going to teach myself how to write web scripts in 24 hours. Okay, I'm going to go buy all those books, like PHP for Dummies and An Idiot's Guide to web scripting and so on and so forth. And especially the ones with CD-ROM, so I can copy and paste code. Right? Because you don't want to look at an entire page of PHP code and type it in, right? You just want to copy and paste. And all of these people are making lots of money. I mean, these startup companies have to compete with each other to get these employees. So they will throw in lots and lots of extra stuff to keep people working for them instead of the company right next door. Okay? So they will buy you breakfast, lunch, and dinner. We are not talking about Burger King here. We are talking about catering service. Okay? At dinner time, somebody's gonna roll in, with the heated plates and whatnot, smoked salmon, okay, grilled salmon, sashimi, whatever. Okay? Whatever you want is whatever they will get to keep you working in the office. Okay? And then what happened in 2001-ish? Well, these companies, a lot of these companies could not show any profit after a year or so. And venture capitalists are not patient. Okay? They're not going to sit around and go, well, we'll give you another 5 years and then we'll come back and check on you later. Okay? After a year, you don't show any profit, they'll be on you. Okay? And after 2 months of no more profits, they're going to pull the plug. Okay, so a lot of these startup companies got their plugs pulled, in 2001, at the end of 2000 and 2001 throughout 2001 and 2002. A lot of these companies, basically got their plug pulled. What happened to these people who were employed by these companies who are now just disappeared?
My stepdad called those people unemployment.
Well, okay, the high schoolers are easy, right? They just get back to high school. The undergraduates, easy, go back to school. Okay, the graduate students, easy, go back to the research, right? But you still have a whole chunk of people who have no schools to go back to, and they become unemployed, unfortunately. Okay, so how does that relate to this? Well, it has to do with, this may help decide whether you are one of those people who will get fired and not be able to find a job for a while, or you'll be one of those people where they will just go, well, you know, we'll have to cut your salary, but we'll keep you. Okay, that really helps to make a difference. What do you think makes a difference? If you are the employer, okay, so let's say we're not talking about a startup company where it just completely disappears, okay? So let's say we're talking about a larger company like HP, okay? Now HP, you know, when it is not making enough money, it has to, you know, let people go. At least, you know, that's the new culture of HP. You know, the old culture is they never let people go, but the new culture, you know, they have to let people go. How do they decide, you know, who to let go and who to keep?
Who's the most valuable?
Well, from other companies that I've seen shut down, a lot of the time they try to turn like 2 or 3 positions into one position. So they'll pick somebody who's either like a really good multitasker who can handle the job, or somebody who has lots of different experience in different fields.
Okay.
So they can consolidate the people they have.
That makes perfect sense, and that's also partially why I think double majoring or having a major and a minor is going to be helpful. Yep.
I'm just going to say, I have a really good friend, my father's friend, works down in San Diego for John Deere Water subdivision, and John Deere Water subdivision was just sold. He was retained because he's a chemist with a minor in computer science. He's a very intelligent individual. He was a director of an engineering department for John Deere Water, and he was retained, or he's on a retainer right now as the company is letting everybody else kind of leave and figure out what they're going to do. He's on a retainer simply because he does have a good major.
Okay, that makes sense. But in the context of a developer, you guys know what a developer is supposed to do because we talked about it at the beginning of this, you know, semester. What do you think is valuable? You know, what quality is valuable in a developer?
It's someone who, because it's like they're the contractor with the architect, someone who can actually understand the architecture, what the mathematician is doing.
Okay.
The models themselves.
So someone who has a deeper understanding of the application instead of just, you know, a surface understanding. Okay, very good. Now, what do you think happens when people copy and paste code from books called, you know, Learn PHP Scripting in 24 Hours?
They get hacked.
Okay. They get hacked. Okay, that's exactly it. That is exactly it. Okay. People who write books like that, they focus on getting results, right? You know, I'm going to show you how to connect to a database and be able to show, you know, the data, you know, in an HTML document. Okay, and that's what they want to show you, and they will do the simplest possible code to show you exactly how to do just that. Okay. Do you think security is high on their priority list? Nope. It's not even on the radar, right? Okay. The security was not on the radar. So all of these people who copy and paste code would just say, copy, paste, change a few names, test the script, it works, I'm good. Okay. Moving on. Okay. Oh, it's dinner time. You know, I got to get my sashimi, right? Okay. And then that script gets pushed, right? It get published. Okay. If you are a hacker, what would you do? Okay. Knowing that there are a lot of new websites developed by newbies. Okay. What would you do if you are a hacker and say, I want to be able to kind of get into the database of these corporations to see what I can get? Okay. What would you do? You buy all the books titled Learn PHP Scripting in 24 Hours. Okay? An idiot's guide to web scripting. Okay? Something for dummies, and so on and so forth. You buy all of those books, and then what do? You go through the sample code line by line, and then you ask, is there a security hole here? Is there a security hole here? Is there a security hole here? Okay? Once you identify those security holes, then you say, oh, I can exploit this, okay? You know, because I can write a query like this, you know, in a URL, and that will basically, you know, do the SQL injection. You can look up those words, you know, on Wikipedia. Then you can do an SQL injection and then the query or the web page will do a lot more than what it is supposed to, because now you can tag on additional stuff to the SQL query, so now it's returning a lot more data than it is supposed to. Okay, so hackers would do that, and then a lot of the websites that were developed during the .com boom had security problems because of that. Okay, so you're letting go of people. At the same time, you also have web pages to fix. Okay, so now you have a problem on top of a problem, because one, you don't have money to keep all the employees, all the programmers, and on top of that, you have all of these security issues to fix. What kind of person can basically go through the code and figure out what is wrong with it, what potentially can be wrong with it, and to fix it? People with what kind of skill set? Programming, troubleshooting. Okay, troubleshooting and analytical, be able to work things out logically, work things out in a basically logical fashion. Okay, and that's why I'm bringing everything back to this topic here, because what I think is this way of thinking, thinking in terms of precondition, postcondition, and verification, will help you understand the logic of a program a lot more than just I think I can trace this program. Okay, instead you're basically questioning, if I can get to this point, what does that mean? Okay, if I can get to this point, what does that mean? Okay, so we are looking into those things. So I'm just going to read a little bit of what I have written here. Dijkstra, which is one of the giants in computer science in recent years, he died a few years ago. He wrote a lot of textbooks in computer science. Okay, a lot of algorithm books he has written, and his belief is quite extreme. Okay, he believes that computer science should be treated as a branch of mathematics. Okay, in other words, there should be no computer science department. Okay, this is actually just math. Okay, this is mathematics, and instead of in addition to algebra, calculus, trigonometry, and so on, you have computers. Okay, programming as one field within mathematics, and that's his take. In a lot of universities, you can actually see how that happens, because in a lot of universities, the computer science department is a spin-off from mathematics. So his view is kind of extreme, and a lot of people do not, go for, this type of, approach. And then the other person is Knuth. Knuth is still teaching at Stanford University, and he has the foresight to say, well, if we improve the tools, maybe programming can be done by more people. Okay, maybe people without a strong background in mathematics can do some programming too. That's his belief, which is kind of opposite to Dijkstra's belief, because Dijkstra says you have to have a math degree first. Okay, and Knuth says no, depending on the tool, with good tools, just about everybody can do programming. If I go to App Inventor, and let me show you, how programs are written here, then you might agree with Knuth. So, save. Open it. This will take a little bit of time. So while we are waiting for this to start up, I'll go ahead and continue the discussion. Okay. What would be the difference? Now, if you want to program a VCR, which is cortical programming, we don't have VCRs anymore, I understand that. DVRs, okay? If you want to program your DVR, it is a kind of programming, right? And if you let someone who's not qualified to program a DVR, what is the worst thing that can happen?
Delete your show.
Yep. Okay, nuke all the shows that you already have recorded. Where are my Mythbusters? They're all deleted. Ah! Right? On the other hand, if you have someone who's not experienced in programming, and that person is in charge of the firmware of my pacemaker, when I have a pacemaker, what would be the worst thing that can happen? bad things, right? I mean, if it killed me in one instant, that would be good, but it may not even happen like that, right? I might keep twitching for a few days before I die. That would be bad. Okay, so depending on what the program is for, there are different requirements, and that's why I think both of them are right. If you're working on something that is critical, you need someone who is very analytical, someone who is going to approach things in a very rigid and formal way. On the other hand, if it is something that's casual, okay, like a game on your phone or something like that, then you might be able to use people who do not have a strong background in logic, mathematics to actually do the programming. I'm showing you this, because this is basically what a program looks like in App Inventor. It really is drag and drop. Okay, so if I want to do something, okay, I'm just going to start some new code here. If I want a button, okay, let me just go back to the app here. See, I have 2 buttons here. If I want a new button, I just go to Basics, drag a new button into the app screen here. Okay, this is called. Let's see, the name of this new button is button 2, okay? I go back to the blocks editor here, go to button 2, I drag and drop, button 2 dot click, and now I can start my coding. In fact, you can probably recognize some of these things that we have talked about in this class already. We have, guess what, conditional statements, right? Drag and drop it here. If you want to specify comparison, you go to math, and then you have your usual comparison operator like this. In other words, you don't have to learn the syntax of anything. All you have to learn is, oh, you mean this little tab here has to match this little notch here. Oh, you mean this little notch here, like a puzzle, has to match that socket over there. That's all you need to do. It's all visual. Okay. You cannot plug in something that it does not belong. Okay, it won't let you do it. Okay. So with tools like this, okay, I'm telling you, last year, my 9-year-old, which was only 8 back then, he was doing scripting. He was doing scratch scripting, little games that that he would write for himself. Okay, it is like that. Okay, but if I asked him to look for security issues, he probably won't be able to think in that, in that type of, in a way to say, okay, this is the intended use of the program. Now, how do I do it, in an unintended way to break it, right? So he wouldn't be able to do it. And that's what, this whole chapter is for. Okay, let me switch back to the notes here. Okay, if I go back up and then go back down again, we are basically going to talk about pre and post conditions, at least for the next 2 or 3 lectures, okay? So next Tuesday, next Thursday, and then probably the Tuesday after that, we'll be talking about pre and post conditions. It has nothing to do with traces, okay? So when you do the homework, yes, those are traces, but when you read the material here, we are not tracing anything. What we are doing is we want the truth. Okay? We want the truth, and we can handle it. Okay? We want the truth before the execution of a statement, and we want the truth after the execution of a statement. And then we chain all of these things, so it will become, we know the truth before the entire algorithm, and then we know the truth after the entire algorithm executes. And that will tell us whether an algorithm is correct or not. So we'll talk about this again on next Tuesday. Have a nice weekend, but don't forget to do your homework and study a little bit.
The assessment of venture capitalists is exactly correct.
Sorry?
Your description of venture capitalists is spot on.